So let me just give you some simple introduction about me. So I have around 7 years of IT experience. So currently I'm working in Cisco. So the first half of my experience comes from system admin. So I was a Linux and Linux system admin. So currently in my project, I'm working on containerizing yeah, more than 20 number of applications that is actually customers are using in the environment. So this is going to be the agenda of today. So we want to see introduction to the containers and Docker and Kubernetes. So before we directly dive into the Docker, it is best to see what's the operating system level virtualization. So operating system level virtualization is an instance of we can have more than one instance of kernel in our system, through which we can actually have an isolated user space. So how many of you familiar with using the virtual environment in Python? Yeah. As similar to that, so we can have an isolated user space inside our Linux or any operating system which supports the virtualization in the operating system level area. So each OS instance running in the operating system looks and feels like a real server to the user using it. So we can just see the model to understand. So in the bare metal server, so we used to have an operating system. So if you see the second model, so how we are might have familiar with the hypervisor based visualization. So where we will be installing the hypervisor on top of the bare metal server, and so we will be we will be creating a virtual hardware by using the hypervisor, and then we will be installing the operating system on top of the virtual hardware. So that is how we use to consume it. So we can have as many number of virtual hardware we need. We can create it and we can have an operating system installed. So we can see the third one. So that's a variable server again. So we can have an operating system installed. So instead of having an hypervisor, so what you can do is we can have another instance of operating system kernel running in my host machine. So when I say host machine, this operating system is a host machine. So I can have another instance of the kernel that can provide a look of a real server. So I can have a user space, I can install application binaries, I can run an application there. So I can switch to, I can have means as many isolated environment I need, I can have it. So that's what called container here. So we can have as many as you want. So similar to the approach, we can see the final one. So in the bare metal server, so again we can have an hypervisor. So we can create a virtual hardware. So we can in the virtual hardware we can install an operating system. So again the same thing. So you can have that kind of operating system also. You can have another instance of kernel. So on top of it you can actually run a container. So in the real-time use case, you can see that the hypervisor as a VMware ESXi or the OpenStack. So we can have an OpenStack instance created. So in that instance, we can have a Red Hat Linux or a Ubuntu which supports this operating system level virtualization. So most of the kernel 3 of Linux version supports the operating system level virtualization. It has a support to the Docker as well. Um, so we can have a container there as well. So in this slide, so I'm going to just give you a demo of the series root J. That's the basic foundation of having the isolated Linux environment, so that you can gain a better understanding about it. So here you can see I have a Ubuntu 16.04. So I have a simple command called JQ for passing the JSON. So in the directory I have kept an image file. You can see I have a Ubuntu 16.04 server image. I have a Ubuntu 16.10 server image. So I'm going to mount this image. I'm just going to create an isolated environment with the image. You can actually see it now. So you can see I have a directory called aroot inside the PMP. It's empty. So I have a command to mount the images. Okay, it's mounted. So I'm not sure about the error. So still we are in the worst operating system. So you can see that I'm running as the user called Raja. So since I mounted the image into the EMP view, so now I'm going to switch my system control to the isolated Linux environment I have. So for that I'm going to use the cd command. So now I'm into the directory. So the kernel actually, so I'm into the directory. So whatever command I'm running, so it is not running in the global system. It is not running in the host operating system. So whatever we do here, it is going to apply in the isolated or isolated version of the operating system running here. So here you can see the LSB version. So it is 16.10. So my host operating system is 16.04. 0.02, and also you can see there is no JQ command here. So how I can actually get out of this, come away from this C to J. So now you can see I just give a simple exit. So I'm now using the host system. So here you can see LSB release, it's a 16.04. So similar to that, I can have as many image I want. So I can actually mount it. So I can do changes, I can run my application in the isolated user space. So it is just to give you an idea about how we are creating the isolated operating system environment to run a container. So if you see what's the advantages of it, so I can have an isolated operating system, so running in this root. So I can actually install all the application dependencies. So I can actually create a toggle of it. I can actually distribute it to you. You can run in your version of Linux that supports the operating system level virtualization, right? So we don't need to do it everything by manually like this. So there are tools available using which you can achieve this. So achieve of distributing this isolated isolated server as a container. So that is when the Docker comes into the picture. So we used to have a LXC Linux native container. So we are not going to deeply dive into the LXC. So our part of agenda is to see the Docker and the Kubernetes. So it is clear. So as I mentioned, so it provides a rapid application development. So container includes the minimal runtime requirements of the application. So reducing the size. So what I showed you, it is not reducing the size actually. So it is not an actual LXC Linux container. So when I say container, we don't need to have an entire operating system libraries and things like that. So it can have just a minimal libraries and things. So because the major part, it can use the base host operating system libraries. So what I showed you is to just give you an idea about the isolated operating system user space. So now we will see what is the use of Docker. As I mentioned, it would be hard for us to manually do the change, means manually just do the application installation just keep track of it and create a toggle of the isolated server and distribute it, so it will be very hard. So we can't ensure that whatever different, so there may be differences with the host operating system, so that we can't actually ensure in the end person who is going to use this container. So when you use a Docker, so Docker promises that whatever the image, we will be creating a Docker image. So rather than using the image provided by the Ubuntu or CentOS, we will be using a Docker image. So when we use a Docker, so you can actually distribute this image to any person, you can actually use it in a server where the same version of Docker is running. So Docker promises that the application will run as like it is running in a machine, as like it is the built and deployed mechanism. So it is basically a container management software through which you can actually build an image. You can run a container, so do things. So it provides an image format to build and distribute the image. So when I say image, the image will be containing the libraries and binaries in the operating system, and you will be installing an application libraries, and you will be packaging it as an image, and you will be delivering to the customer. So the portability across machines, that is what enables the portability. You can actually distribute this Docker image to anyone who has a similar version of Docker engine service running in the host operating system. You can just directly go and start it and use it. So we don't need to bother about installing. We don't need to give a guideline what are the packages need to be installed in operating system that occurs by the application. So we don't need to tell anything. Just build and distribute. So it provides the portability. So it has version control and component reuse. So when you say, so we will be seeing how we can build a Docker image. So we may have multiple steps to for installing our applications. We can go to it's like a Git checking. So you can actually go to any kind of commit. So those things we will be seeing in the later part of the slide. So you can share it. So it's a lightweight footprint. So as I mentioned, from the host it is actually basically using the full capacity of the host operating system. So you need to have just a minimal libraries installed in the image. So it's a simplified maintenance. So it actually simplifies, means I mentioned so my first half of my experience I worked as admin. So there are a lot of maintenance activities we may have to do. So I think we don't need to care about everything when we use a Docker along with Kubernetes. So you will be learning the Kubernetes so that you can actually get to Kubernetes. So this is the same thing I mentioned earlier. So in this hypervisor based virtualization, so we used to have an infrastructure and the host operating system and hypervisor. So we can have a virtual hardware. We will have to create a virtual hardware to install the dedicated guest operating system. And then the binaries and libraries required for the application, you can install and run the application. So that is with the hypervisor based virtualization. So when it comes to container based virtualization, so you can have an infrastructure hardware, you can have an operating system, you can have a container engine. So in our case, we are using Docker. So there are RKT container engine also available. So Docker is pretty much famous nowadays. So within the use of Docker engine, you can have an image created which contains the binaries and libraries required for your basic operating system libraries and binaries, and your libraries required for your application. You can run the application as many as you want. So you can see how to prepare a Docker image. So this is the basic block when it comes to learning Docker. So we can create a directory in the name of the application that you want to actually build and build with you. So it's just a simple app, direct entity. So you can create, you can move to the directory and create a file in the name of Docker file. It's case sensitive. So you have to create a Docker file. So there are certain syntax that we will have to follow when we create a Docker file. So wherein the first one is from CentOS 6. That's the base image that is required for your application. Say this my app, simple app application requires that can run in the CentOS 6. So I can actually mention the base image of this CentOS 6. So I can even build a base image that I want. or else there are base images already built and available in the Docker hub. So I'll be telling about the Docker registry in the next slide. So there are base images already available. So what Docker does is when you build a Docker image, so it will look for base image in your local system. If it is not available, then it will pull the base image from the Docker hub. So we have a syntax with run. So with that you can run any kind of commands inside the image. So there you can actually provide the installation and preparation step for your application. So like run sudo apt-get, you can actually install your application. And then there comes the entry point. So this entry point is so if you see the life cycle of the container. So when you run a container, so it needs some kind of binary or program to run. In case there is no program, it will actually die. As soon as we start the container, it will actually die. So we need to give us some kind of program to get it run. So the way how we can actually provide the program to the image itself, you can use an entry point. So where you can actually mention you can directly provide the binary if you want, or you can have a script through which you can call your application, and moreover you can even configure the application in the script. So there are other syntax also available. You can use the env to set a environment variable when the container starts up. So that environment variable you can pass to a command line when you are running the container. So that environment variable again you can use in the implement script. So when I say this is a Docker image, so when we build this image, we are not going to start the application. There will not be any active instance of the application running part of the image. So all we do is we will actually build an image with all the application libraries pre-installed, and we don't start up any applications. So when we run the image using the Docker, so that is when the entry point will be called. So the entry point would have the scripted tool called call and run the application. So to get you a better idea, so using Docker build command, you can actually build it. I20 is to provide the image name. So where the image name itself, the starting of the image name would contain the registry name where it has to go to, where we are going to store this Docker image. And it contains a version. So this is going to be an example Docker file. So you can see from Ubuntu latest. That means whatever Ubuntu, it will actually take the latest version. In case if you have the Ubuntu latest version tagged image in your local system, that will be taken. So otherwise, you will actually download it through the Docker hub. And so the maintainer, you can give the author name of this document. And so the run, you can see doing a sudo apt-get update to get all metadata updated. And so in this example, we are explaining the MongoDB. So the port that this container is going to expose, so that is mentioned in by using the expose keyword. So there is a command syntax. So this command is like a kind of command line argument. So you can pass this command line argument directly into your entry point script. So that is the idea here. So if you don't want to hard code it in here, so you can you can remove the part. And if you wanted to add more command line argument, so when you are running the Docker using Docker run command, so you can provide this argument. So the entry point, as you can see, there is a MongoDB binary. So two stars of the MongoDB. So this -2 port 27017, this command line argument will be passed to the entry point to bring up this MongoDB service into particular port and get it branded. So these two CMD and entry point will run when the container starts up. So this is going to be triggered during the runtime. So now we are going to see the Docker registry. So I mentioned to you about distributing this image. So it is not, will not be a very hard way to distribute using SCP or something like that. So we can't just use maybe you do build this image for your organization, so we can't just use a public domain to do that. So there is a centralized Docker registry that we can actually build if you want. So there is a public registry also available. So it's just like similar to the Geek right now actually. So you can actually build a container image. You can actually push the container image to the centralized Docker registry. So whenever you want it, you can actually pull it. and you can actually instruct your fellow workers to just you can mention the image name and person so that he can actually make a pull of the image and just try it out. Just manually to distribute, and there are kind of version controlling also. It is possible to um, so when if you see how the authentication is happening, there is authentication also we can configure in the Docker registry. So before we do the Docker pull, so we will actually log into the particular Docker registry using the Docker login command line. So once we log in, we will be able to push and pull the images. So the example public Docker registry is up.docker.com. So Docker provides this public Docker registry. So this is being used by many developers, and as well as if you see the Ubuntu, they are officially releasing their Ubuntu and CentOS images in this software Docker.com. So when you give from Ubuntu for data, so it will be automatically downloaded. So we don't need to log into the Docker registry. So it has all the logic to Docker registry by default. And when you want to have the local registry running in your organization, so you can use a JFrog artifactory that is available. You can actually make use of it. It supports the Docker registry feature. And Docker registry also available as a container, so that you can actually download and run the container and make use of it. So by default, just the tips what I can give you is by default this Docker registry provided by the Docker will run in a Unix package. So you may need to have a Nginx container or some other web server container. In the host operating system itself, you can run the Unix service that uses this upstream Unix daemon application to use it in your internal network. So this is how you can run the container using Docker. You can use a Docker run with the image name and the tag name. So the container will start up. So what this container will run is the entry point script. What we have given in the image, then will be triggered when the container gets run. So if there is no entry point script, what will happen is when you run the container, so it will actually run, it will die. As soon as it starts running, it will actually die. But there are ways to keep it alive by using this -d. There are articles already to do that. And when you want to actually run a specific program, when you are starting with the container, so you can do it by just giving the program at the last of the argument. You can just mention the program, you can run. So the way how you can actually log in case if you have an existing container running, so that you can see using Docker ps command. So as like the ps command, we have a Docker ps command. So when you run the Docker ps command, so you can get the list of the actively running Docker containers. So you can use a exec rather than using the run. So for that, you can provide the container name and the program. Sorry for this, we don't need to give this image name and tag name. You can give the container name. So when you are running the container, you can give the container name using -n name argument. But by default, there will be a name assigned to it that will be unique across the system. So you can actually make use of the name or ID. If you wonder how I can actually log into the particular Docker container which is running already, you can use the similar ID. So I means an interactive terminal. I means interactive key is a terminal. So the program that I can do is a bash. So as you know, the bash provides a shell. So this when you run the Docker exec, you can give an icon key, and then at the end you can do the bash program. So in case if the bash program is available in your container, that will be executed. So that you will get a terminal you will get a shell to the Docker container. So you can perform any command you want. So if you wonder who is using this Docker service, I can just give you a couple of example cases. So you may have familiar with the Travis CA.org, where when you do a Git commit, so it is used for continuous integration. So you may write a YAML file by mentioning the list of requirements you want to install for your application, and the command line that triggers this application testing. So you will be given in the YAML file. So what in the backend happens is, so, the Travis.ca spins up a Docker container. Then it installs all the application. You might have defined the dependencies in the YAML file, so that will be installed in the container. So and you might have given the program to launch the test of your uh, your code, so it will be triggered to part of when the container is running using the entry file. So this is what happens in the tabs here. So code envy also you might have familiar in using the code envy. We can have a workspace that we can access across multiple machines. So so using the code being the code envy also using the Docker to give you a workstation. So you can actually write the code and whatever workspace you are using the code envy. So it is basically a Docker machine. So when you're actually stopping the workspace, so what actually it does is, so it will actually build a new Docker image. So that contains all your changes. So by default, Docker is actually a read-only image system. So whatever you do, actually you have actually when you have to save it, there is an export option. You can just only get it changes. There is a diff that will actually provide only changes. So with the diff, it will actually build a new image. So the new image will be stored in their servers. So when you are actually opening this workspace again, when you're starting the workspace, so they will actually spin up the Docker container again, so that you can get to access to the all the files that you access to from any previous PCs. So this is a real-time use case for this Docker. So, so this ends with the Docker. We can actually so dive into the Kubernetes. Why we need a Kubernetes? So before we go to the Kubernetes, we can actually basically see if we have a home with a 1,200 square feet, so without any partition. So we could be hard for us to manage things. Right? We can actually manage, but it would be hard for us to manage things. So we don't know where we are keeping, we don't know what we are actually throw it out. So for that, what we are doing, we are actually partitioning with the bedrooms and kitchen. So in the similar way, so it will be hard for us to manage things with the Docker itself. In the real-time use case, we may need to provide a fault tolerance, high availability for the service running in the container. So we can't actually manually do things. So if you know the programming, so it would be hard for us to write a programming to build up this highly available systems. So this Kubernetes is already available, so which we can actually use. So Kubernetes is built based on the experience with Google, the 15 years of production experience with the Google. So by keeping that in the mind, so this Kubernetes have been built accordingly. Kubernetes is basically a production grade container orchestration. So what it does is basically it deploys the container for you, and we can actually tell the Kubernetes to we can instruct the Kubernetes to make the availability of the container. We can do many more things with the Kubernetes. So Kubernetes works in the master worker model. So as you can see in this picture, we have a one master controlling this three worker process worker instance. So basically, when I say the master, that is actually it can be a virtual machine or it can be a physical machine. And when we say the medium, so these three workers basically this is also can be a virtual machine or the host of virtual machine or any parallel server. So at virtual box. Here you can see I have a master here, I have a medium worker servers, I have not powered it on because I'm not going to launch something on the online because I can't complete the department. So now, when it comes to Kubernetes, we don't actually we can now we no need to interact with the workers. So workers is the server instance that is actually running the Docker engine. So master will not run any Docker engine by itself. So we don't directly as user we don't directly interact with the worker to land in Docker containers. So we'll be instructing the master to run the container for us. So the master, so in that case, master has the capability of scheduling this container in any kind of worker it has a control. So when we instruct a master, so we don't actually instruct that we need a container. So the Kubernetes has an object model. So the basic building block of the Kubernetes is actually a pod. So the pod object is the basic building block. So through which we can actually instruct the master to launch a container. So you don't need to worry about what is pod that we will be seeing in the latter part. I can give you an introduction to the pod. So pod is a collection of containers and the resource used to make a container. So that we can actually group together and we can create a pod object. That pod object we can actually provide it to the master. So master schedule the creation of pod in any vector it has a control. So you may have a question, sir, why we need a pod, why we need a pod object when we have a container? Why don't we just directly mention it as a container itself? So assume that you have a Docker registry in your organization, and you're going to if you have a single instance with the Docker running, you might have done the Docker login to the particular registry, right? For doing the push and pull of the images. When you're running the container, it will actually pull the images from the registry to run the container. So in the case of Kubernetes, it's a clustered system. So we can't actually ensure that every worker does this Docker logging to make sure that it can actually pull the images. So in the production scale, we may have a more than 100 number of workers running in the system. It would be hard for us to manage this Docker login, whether it has an access to the Docker history and whether it can able to pull an image or not, we can't ensure. So that is why we need an object. So with the pod object, what we can do is we can actually we can define what are the resources needed to run this container in a group, in a set of group, and we can even provide an object underneath the pod object. You can provide an object called image secret. So that secret has a key authentication to so that will be synced across this worker by the Kubernetes. We don't need to do it manually. So that secret would contain the key to do the Docker login and pull the images. So that is when we need a kind of objects. That is why we are not actually just directly there is no direct container object available. So we will move on to Kubernetes. So Kubernetes basically group the containers and provides scheduling and replica, scaling and monitoring and much more additional functionality. So in this case, scheduling, I mentioned when we can expect a master to run a container for us. So the master can pick up any worker according to the details of the application. So this is what it is called scheduling. So I can instruct a master to keep the two number of copies of my application running all the time. So that is what called a replica. So we can actually increase the replica and decrease that is what scaling all about. So the replica also, the Kubernetes, what is, if you wonder what is monitoring, when we instruct Kubernetes to create, have two copies of the same application, so it does for us. So in case if there is any failure in the particular container, it senses. It actually has a self-healing mechanism. It actually launches one more container for us. So that is what monitoring, and it has a much more additional kind of functionality. I hope with that you now you got to the point where why and the Kubernetes is important when it comes to running it is similar to the vCenter in the hypervised environment. If you are familiar with the VMware environment, VMware virtualization, we would have a ESXi. You can actually directly ESXi. We can actually use the vCenter service available. We can actually build a vCenter server to add this ESXi server to provide all the capabilities. So the Kubernetes is similar to this vCenter. So if you are familiar with the VMware virtualization, you can actually correlate it. Some of the terminologies are used in the Kubernetes world. The master and master as a controller, scheduler, and API services. You see what is controller and scheduler is the algorithm and logic to schedule and what nodes are available and where it can schedule. The controller has actually the replication controller and the monitoring controller. So those kind of things are controller service. We can categorize these services. The API service. So there is a API service running in the master that you can actually consume. You need to actually talk to the master. As a user, you need to talk to the master to instruct the master to launch the container for us. How do you talk it? So there is There is service running in the master. There is a CLI provider. You can actually install the CLI in any of the operating system that's available. You can just install in your laptop. All we need is just an access to the master in the network. That's all we need. So we can actually send a context to reach the master with authentication and all this. So that you can interact with the command line. So there is a UI also available. So you can actually interact and install the master to and master is responsible for managing the cluster and coordinate all activities. So when it comes to load, what kind of service category we have? We have a user service. Through this service, node receives all the instructions from the master. Since the master is in the user service, and also a node will run the Docker service to land any Docker containers. So as I mentioned earlier, the node or master can be a VM or a physical computer. According to the need for it. So now we will just see what is Kubernetes for. Kubernetes for is just grouping the containers, the collection of containers on the SAR resources used by the containers. We can actually just group it and just call it as a pod. We can actually instruct this pod to be created in the master. We can instruct the master to create it for us. We can either do it through command line or do it through the UI. The if you see the commonly used way is we will have a one container after pod. So there is a common way. If you what is the need of having the two container and the SAR UI? So you can actually this container one running a UI service in this container, two is running some kind of data service. The UI is going to read the data, then show the SAR value, while the container two is going to display it. So some kind of this tightly coupled stuff you can actually move the containers and just run it in a Kubernetes pod. Or you can actually go to create two different pods, one runs in the UA, one runs in the pod, but you will have actually create a kind of services object to make the connection between these two pods to work together. So now we are going to see how we can actually create a Kubernetes pod. So we have a JSON and YAML template is supported when it comes to Kubernetes, and most of the it is actually the internet is find a YAML template. So this is actually a basic simple template through which you can actually manage this part. You can set them up to manage the part. So you can use kubectl command line that we will discuss in our later slide. If you just go through this template, this is the API version, and you can see the kind is a pod. The thing itself is going to create a pod object. And the metadata, his name is going to be the pod name. So we are assigning the labels app for my app. So the reason for a label is you can go and see that you can just see the default labels available in the system. So when you list out a pod, so there you can execute ctl get pod command. It will actually give you a list of pods running in the container. So it basically to provide the default labels like status whether it is running or not, the name of the pod. That is what the label is. You can have your custom label. So here I am creating custom labels for the app. So I am going to name it as my app. The reason why I am doing it, I can actually when I do the kubectl get pods, I can just view the label icon capital and the label and value, so that I can just get only one this my app pods. So this is not only just for managing purpose. So this will be used by services. So we can have a cluster directly created. So we can create a selector there. So we can provide this label as a selector there, so that the clustered service will just query for all the pods with the label containing this name, so that it can provide a VIP to reach this pod. So we will be seeing those details later on. So this we have a specification about the containers, the container name and the image, the command that is going to be triggered using the container, and it is actually started. So that's about the Kubernetes pod. This is a replication controller. There is one other object available in the Kubernetes. This object is on top of the pod. So on top of the pod, we are going to have this replication controller object. So we don't need to create a replication controller object independently. Like we don't need to create a replication controller object separately and the part object separately. So when you are instructing the Kubernetes to create a replication controller object, you can actually instruct in the same template itself. You can actually mention the specification about the container and how it is going to land. So the purpose of replication controller is we can actually provide a replica. That means how many number of copies of my application needs to be run in the container. Means how many number of container needs to be run in my Kubernetes environment. That we can give. So this is actually a simple template for Kubernetes replication controller. So similar to the kind we have seen a part in the previous slide. Here you can see replication controller. So the remaining things are saved. Here you can see another option called replica of 2. So that means I am expecting that I need a 2 number of Nginx server I needed in my environment all the time. So it has a monitoring, so in case there is a failure, it will actually create one more for me. So the reason why I said that it is actually a kind of superset of the part. So it, as you can see, that under this kind of replication controller, so we can have a specification about the part. So when you delete this replication controller, there is an option to delete it. So it will actually delete all the resources underneath under this replication controller. It will actually delete the part and everything under this replication. So here comes this Kubernetes deployment. So this is one about this replication controller. It is actually as of now it is a topmost object available in the Kubernetes object model. So what the deployment does is it provides, as like the replication controller provides replica option. This deployment has we can actually upgrade our deployment. We can actually roll out the deployment. So like I can have a 1% of my application running in a separate deployment. So I can actually roll out. I can actually put the new changes. So it provides all the facilities for us for doing. So when you similar to that, when you actually delete this deployment object, so all the objects under means all the specification under this will be deleted automatically. You can see there are two specs. That contains replica, replication controller, other for container. So now this is a Kubernetes CLI specification. So you can execute CTL get parts. So to set up this kubectl, you can actually install this kubectl anywhere in your workstation. You will actually set a context to reach the particular Kubernetes master. So once you've done that, you can use a kubectl get parts to get the list of parts running in the system. You can use a kubectl get deployment for to get the deployment object. You can use a kubectl get RS to get the listen object. Similar to the get, we have delete. You can actually following by the parts, you can give a part name to get it deleted. Following with the deployment, you can actually give a space in the deployment object name. So now this is the way we will create. We will instruct the master to create any kind of object in the system. So we will use the kubectl create -f. We can give the YAML file so it will be created. And when you have to delete it, what you can do is, as soon as the kubectl create the -f, you can use the kubectl delete the template, so that whatever objects available in the template will look whether it is currently available in the system. If it is available, then it will actually delete it. And to see the par information, you can use the kubectl describe command to see the par information. As you can see, par slash the par name, so it will actually provide the information about the particular par name that I am giving. So it can be a slash, or you can actually give a space and give the par name. The parts can be similar or to it doesn't matter to the kubectl. So when you want to see the log files, so basically when you do the kubectl logs, so what are the logs produces by the entry point script, that you can actually see through this kubectl logs. So in production, what do we do is in the entry point script at the last when after I start up my application, so I will be giving the tail-f of my application log file, so that I can actually directly use the kubectl logs to see the logs going around in the system. So the way to log into the container, I explained about the way to log into the Docker container using Docker CLI. That is very similar to the kubectl command. exec-it, you can give the part name, and using -c you can give the container name and the program that you want to run. So here comes the scaling. So at last we reach the slide which actually matches the title of this, uh, the topic of this talk. So Kubernetes scaling. So you can do the scale down or scale up using the command line. It is very easy to do it. QCL scale. You can provide the deployment object name, and you can type in the replicas file. So so as we seen already, we can create a replication instead of using the deployment object. We can use a replication controller object, right? So when we want to scale a bit, instead of using the QCL scale, the deployment and the deployment object name, you can use a replication controller slash the replication controller object. So this will actually work. So how do you scale up? So in case if I am running the my app with the number of copies of 10. So if I'm instructing the Kubernetes with the replica of 5, then it will actually acting like a scale down. It will actually terminate the 5 number of pods for us. The scale is similar to that. So if I'm running the 10 number of my app application container pods, so I can give a replication of 75. It will actually increase it. So there is a feature called horizontal scale. So that is actually a dynamic scaling. So what we have seen here, so that we happen dynamically, we can instruct the master to do it for us. So using the QCL auto scale, you can do the deployment object, and you can mention the minimum number of pods that you want, the maximum number of pods that you want. So what is going to the criteria for this minimum and maximum is the maximum is the CPU percentage. So I have mentioned the CPU percentage as 80. So in case, so by default when we launch this, 10 number of my application copy will be running in my system. So if for one part, the node running the one part, so in case if it reaches the 80% of the CPU, then it will actually launch one more part for us. So it will go up to the 50, that is what max. So the same thing you can actually instruct the Kubernetes master through the template. So you can see the kind horizontal for autoscaler that it can actually use to launch this thing. So I'll just give a little introduction about the config map object. So we have seen that we will be installing all our applications and building a Docker image, and we are going to distribute it, right? And so now what we do is usually we will actually deliver this application configuration file along with the application package itself, right? So in that case, building an image and you are going to run this image in a different environment with the different properties you need. You want to change the application properties. You don't need to actually change the application properties and build the image again according to the environment. So here we have a config map object. What we can do is instead it is added additional facility available. Instead, you say if you are running a JBox or any kind of application, so you might have a properties file already in the system. So we will have actually the idea of having the config map is to decouple the application configuration from the image. So we will be keeping the application configuration in an object called config map. So we are going to mount this config map as a volume so that we can actually get access to this properties file inside the container. So this way what we can achieve is we can actually change the application properties on the go by just instructing the master to do so, instead of actually reproducing the new image with the different application configuration. So how we can do this, you can see this is a game.properties file. So this properties file is required for my application. So instead of hard coding and keeping it in my image itself, so I'm going to have this config map object. So you can see these are the application. So as similar to the game.properties, I can have a UI.properties as many files as I want. I can actually have. So we have another object called Kubernetes secret. So when it comes, so this is similar to the config map, but what are the sensitive information you have and that you wanted to protect and reduce the risk of accidental exposure of this image, the secret can be used. By default, it uses the base64 encoding to protect the accidental exposure. So what we usually keep is we usually keep the username and password, the authentication mechanism to log into the particular Docker registry. We will give them the Docker secret. So when we are launching a pod, we will be attaching this secret object with that. We will be giving the in the specification of the pod, we will be giving this secret name as well. So there is another object. This is going to be the final one, which is services. So we may, so as we've seen that we can actually rapidly scale up and scale down the Kubernetes. But we don't want to give the impact to the user. So what we do is basically we have to decouple this part with the information that user has to access the application. So one thing you can actually consider easily is an IP address. So you can see if I have a service, a banking service, I may have a website mybank.com. So we can have a services object created that will provide a virtual IP for me in the Kubernetes cluster. So with the services, I can choose a selector. You see this? I can choose a selector. So I can give the label name app equal to my app. So it has a what every time what it do is if user actually reaches this bank mybank.com. So the user and the Kubernetes by itself don't have knowledge of where it is running and how many container policies running. What it do is through the service it will actually go to this selector and it will actually get the list of the pod and you can have a load balancing policies set. You can have I level means HA policy set. So there are facilities available. So you may have 10 number of copies of your same application. You can use it for load balancing along with the high availability and fault tolerance feature. So for that purpose, services is useful for. So these are some of the online resources that we use for learning data analytics. So that's all. I hope you like it. Any questions? So this is basically fits for a kind of web scaling.